87% of AI models on Hugging Face haven't been updated since 2024, and that's actually accelerating innovation.
Wait, are you saying abandoned models are somehow helping the ecosystem? So we're covering the new metrics that matter, which regions are dominating, and why the old leaders are losing ground.
By minute 4, you'll know exactly which models to trust in 2026. Let's get into it.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today we're diving into State of Open Source on Hugging Face, Spring 2026.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about something that's fundamentally reshaping how we build AI systems. Hugging Face just released their Spring 2026 State of Open Source report. And Alex, the numbers are staggering. We're looking at a platform that went from hosting a few hundred models to millions in just a few years.
Millions? I knew they were growing, but that scale is mind-blowing. What's driving this explosion?
It's the perfect storm, really. You've got developers who are tired of paying OpenAI's API fees, companies worried about vendor lock-in, and this whole movement around AI sovereignty, especially in Europe. But here's what's fascinating. Hugging Face started as a chatbot company back in 2017. Nobody saw this coming.
Wait, a chatbot company? How do you go from building chatbots to becoming what everyone calls the GitHub of machine learning?
That's the billion-dollar question, isn't it? Clement DeLange and Thomas Wolfe made this pivotal decision around 2019 to open source their NLP tools. They basically said, let's give away the infrastructure and see what happens. And what happened was they accidentally created the default platform for AI collaboration.
So they zigged when everyone else was zagging toward proprietary models.
Exactly. And the timing was perfect. When ChatGPT launched in November 2022, it created this massive demand for alternatives. Suddenly, every startup, every research lab, every enterprise was asking, how do we build our own? And Hugging Face was right there with the infrastructure ready to go.
But hosting millions of models, that's gotta be expensive. How are they making this work financially?
That's where it gets interesting. They're running a freemium model, free hosting for public models, but they charge for private repos, compute resources, and enterprise features. Last I heard, they were valued at over $4 billion. But here's the kicker. They're not just hosting models, they're hosting the entire ML workflow.
What do you mean by the entire workflow?
Think about it. You've got model cards for documentation, data sets for training, spaces for demos, and now they've added storage solutions. It's becoming this one-stop shop for AI development. And that network effect is powerful. The more models they host, the more developers come to the platform, which attracts more models.
It's like GitHub's playbook, but for AI. Create the platform where everyone collaborates, then monetize the enterprise needs.
But here's where it gets really interesting. This isn't just about saving money. We're watching a David versus Goliath story play out in real time. On one side, you've got OpenAI, Google, Anthropic with their closed models. On the other, you've got this army of open source developers building alternatives that are getting scary good.
Are they really competitive, though? GPT-4 and Claude are pretty impressive.
6 months ago, I would have said no. But look at what's happening now. Mistral's latest models are matching GPT 3.5 performance. Meta's Llama variants are being fine-tuned for specific tasks and outperforming general-purpose models. And the cost difference is dramatic. We're talking 10x cheaper for comparable performance in many cases.
So this is about more than just saving money. It's about control, customization, and not being dependent on a few big players.
Now you're getting it. And that's what makes the Spring 2026 report so significant. We're at this inflection point where open source isn't just playing catch-up anymore. It's starting to define the rules of the game. Coming up, we'll dig into exactly how Hugging Face built this massive platform, what their technical architecture looks like, and why some of the biggest names in tech are now contributing to open source AI instead of keeping everything proprietary.
Okay, so let's get into the technical meat here. How does Hugging Face actually handle millions of models? That's got to be a massive infrastructure challenge.
It's absolutely massive. They're using a combination of Git LFS for version control and a CDN network that spans globally. But here's the clever part. They're not storing every model in hot storage. They've built this tiered system where popular models stay in fast access while less used ones get moved to cheaper storage.
Smart. So it's like a caching strategy at a massive scale. What about the compute side? Are they running inference for all these models?
That's where their business model gets interesting. Free tier users can run inference on smaller models using shared infrastructure. But if you want dedicated compute or to run larger models, that's when you need their paid tiers. They've partnered with AWS, Azure, and Google Cloud to offer seamless deployment options.
Wait, so I could train a model locally, push it to Hugging Face, and then deploy it to any cloud provider?
Exactly, and that's the genius of their approach. They're not trying to compete with the cloud providers. They're making themselves indispensable to all of them. The spring report shows that 73% of enterprise AI deployments now involve at least one open source model from their platform.
That seems high. Where's that number coming from?
They surveyed about 10,000 companies using their platform. And when you think about it, it makes sense. Even companies using primarily proprietary models often need specialized models for things like document parsing, language detection, or domain-specific tasks. That's where open source shines.
So it's not really open source versus proprietary, it's more like a hybrid approach.
Precisely. And that's what's driving this explosion in model diversity. The report shows over 500,000 text models, 200,000 image models, and get this, 50,000 models specifically for code generation, each one optimized for different use cases, languages, or domains.
How does quality control work with that many models? There's got to be a lot of garbage in there.
Oh, there absolutely is. But they've built this reputation system. Downloads, likes, community reviews. The cream rises to the top pretty quickly. Plus, they've introduced model cards as a standard, so you can see training data, limitations, biases. It's way more transparent than proprietary models.
Speaking of biases, how are they handling the whole AI safety thing? That's got to be a nightmare with millions of models.
It's definitely a challenge. They've implemented automated scanning for obvious issues, hate speech, violence, that sort of thing. But they're also leaning heavily on community moderation. If a model gets flagged enough times, it gets reviewed. It's not perfect, but it's scaling better than centralized moderation would.
What about the technical innovations? What's actually new in this spring 2026 landscape?
Oh man, this is where it gets really interesting. Model merging has become huge. People are taking multiple specialized models and combining them into supermodels. There's this new technique called model stitching, where you can take the language understanding from one model and the reasoning capabilities from another.
That sounds like it could be a mess. How well does it actually work?
Better than you'd think. The tooling has gotten really sophisticated. Hugging Face released this framework called Transformers Fusion that handles a lot of the complexity. You can basically drag and drop model components and it figures out how to make them work together. Success rates are around 70% for compatible architectures.
That's actually pretty impressive. What about performance? All this modularity must come with overhead.
You'd think so, but they've done some clever optimization. Models are quantized by default now. 4-bit and 8-bit versions are standard. And there's this new technique called adaptive precision, where different parts of the model use different bit depths based on importance. We're seeing 90% of the performance at 25% of the memory usage.
That's huge for edge deployment.
And that's exactly where this is headed. The report shows edge AI deployments using Hugging Face models grew 400% year over year. We're talking about models running on phones, IoT devices, even browsers. Web GPU support has been a game changer.
What about the elephant in the room? Training data. Where are all these models getting their data from?
That's the thorny issue. Hugging Face hosts data sets too, but data governance is still the Wild West. They're trying to implement better provenance tracking, but when you've got millions of models trained on who knows what data, it's a challenge. The EU's AI Act is pushing for more transparency here, which is probably good for everyone.
Stick around. In our final segment, we'll break down exactly what this means for your AI strategy and give you a practical framework for deciding when to use open source versus proprietary models. All right, so for our listeners who are thinking about their AI strategy, when should they be looking at Hugging Face and open source models versus sticking with OpenAI or Claude?
Let me give you a decision framework that's been working well. First question, is your use case generic or specialized? If you need general purpose chat or coding assistance, honestly, GPT-4 or Claude are still your best bet. But if you need something specific, like analyzing medical documents or understanding your proprietary code base, that's where open source shines.
Because you can fine-tune it on your own data.
Exactly. And here's the thing. Fine-tuning has gotten so much easier. Hugging Face's Auto Train can take your data set and give you a customized model in hours, not weeks. We're seeing companies get 95% accuracy on domain-specific tasks with models that are 100x smaller than GPT-4.
What about cost considerations?
Here's my rule of thumb. If you're spending more than $1,000 a month on API calls, it's time to look at self-hosting. The break-even point used to be much higher, but with these quantized models, you can run really capable models on a single GPU. A $5,000 server can replace $50,000 in annual API costs for many use cases.
But then you're taking on the operational burden, right?
True, but it's not as bad as it used to be. Hugging Face's inference endpoints basically give you API-like simplicity with your own models. You're looking at maybe 20 hours of setup and configuration versus thousands of hours building from scratch, and you get complete control over your data, latency, and availability.
What should teams be doing right now to prepare for this open source AI world?
3 things. First, start experimenting. Pick a small use case, maybe document classification or sentiment analysis, and try building it with an open source model. Second, invest in GPU infrastructure, or at least understand your options. The cloud providers all have good GPU instances now, but knowing how to optimize for your workload is crucial.
And the third thing?
Build evaluation frameworks. This is what separates the pros from the amateurs. You need systematic ways to compare model performance, not just on accuracy, but on latency, cost, and reliability. I've seen too many teams switch models based on vibes rather than data.
What about the risks? There's got to be some downsides to this open source explosion.
Absolutely. Model provenance is a real issue. You don't always know what data a model was trained on, which can be a legal liability. There's also the support question. If something breaks with an open source model, you're often on your own. And let's be honest, the documentation quality varies wildly.
So how do you mitigate those risks?
Stick with models from reputable sources. Look for ones with clear model cards, active communities, and regular updates. The top 1% of models on Hugging Face are generally solid. Always have a fallback plan. We recommend a hybrid approach. Use open source for what it's good at, but keep proprietary APIs as a backup for critical paths.
Looking forward, what should we be watching for?
Multimodal models are the next frontier. We're already seeing open source models that handle text, images, and code in a single model. By next year, I expect we'll see open source models matching GPT-4's multimodal capabilities. Also, watch for specialized hardware. Companies are building chips specifically optimized for running these smaller, quantized models.
It feels like we're in this transition period where the old rules don't quite apply anymore.
That's exactly right. We're moving from an AI world dominated by a few large players to one with thousands of specialized models for every conceivable use case. It's messier, sure, but it's also more democratic, more innovative, and ultimately more useful for solving real problems.
Any final thoughts for teams trying to navigate this?
Don't get paralyzed by the options. The beauty of this ecosystem is you can start small and iterate. Pick one use case, try one model, measure the results. The platforms like Hugging Face have made it so easy to experiment that the biggest mistake is not starting at all. And remember, this isn't about replacing human judgment with AI. It's about augmenting what your team can do. The companies winning with AI are the ones treating it as a tool, not a magic solution. The open source AI revolution isn't coming. It's here. And platforms like Hugging Face aren't just hosting models, they're hosting the future of how we build intelligent systems. The question isn't whether to use open source AI, but how to use it strategically to solve your specific challenges. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development from Amazon's hardware labs. TechCrunch just got an exclusive tour of their Trainium chip facility, and it turns out this custom silicone has attracted some major players. Anthropic, OpenAI, and even Apple are now using these chips for AI workloads.
Wait, Apple? That's surprising given how secretive they usually are about their AI infrastructure. What's making Trainium so attractive to these companies?
It's all about the economics of AI training and inference. Amazon's been quietly building these specialized chips that offer better price performance than traditional GPUs for certain AI tasks. The fact that they've won over competitors like OpenAI really shows how the AI hardware landscape is shifting.
Speaking of hardware ambitions, Elon Musk just announced something called Terafab, a joint Tesla and SpaceX chip manufacturing project. According to Let's Data Science, they're aiming to produce a terawatt of compute annually.
A terawatt? That's an astronomical amount of computing power. They're apparently integrating design, testing, and packaging all in one facility to speed up iteration cycles.
Classic Musk, go big or go home. Moving to something more technical, there's an intriguing paper on Zenodo about something called cross-model void convergence affecting GPT-5.2 and Claude Opus 4.6, leading to what they're calling deterministic silence.
That sounds ominous. Essentially, both models are exhibiting similar failure modes where they just stop responding under certain conditions. It's a reminder that as these models get more complex, we're discovering new edge cases.
On a lighter note, here's a great story from Dominic Rudnick's blog. He used an LLM as a personal tutor to prepare for Google interviews in just 7 days, basically brute forcing his way through algorithmic problems.
Talk about practical AI use. He documented his whole learning strategy and the insights he gained. It's a perfect example of how developers are using these tools to accelerate their own learning.
Though, speaking of AI in the workplace, Gizmodo reports that companies like Meta and OpenAI are now evaluating employees based on how many LLM tokens they burn through. They've got internal leaderboards and everything.
That seems like it could incentivize quantity over quality. Just because someone's using more AI doesn't mean they're being more productive.
Exactly. Now for our software releases. VLLM just dropped version 0.18.0, and this is a big one. They've added gRPC serving support alongside their HTTP interface, which is huge for high-performance deployments.
Plus, they've got GPU list rendering capabilities now. Though heads up, there's a known issue with degraded accuracy when serving QM 3.5 with FP8KV cache on B200 chips. This release has 445 commits from 213 contributors, with 61 new contributors joining the project.
The gRPC support is particularly interesting for teams needing lower latency in their inference pipelines. That wraps up today's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.